So on rotational equilibrium, a window cleaner is standing on an equilibrium rectangle board which is held up by two bolts attached to the roof. The mass of the board is 24 kilograms. The mass of the man is 80 kilograms. From the end of the board to the window cleaner is 4 meters. And the whole board is 10 meters. Determine the forces for both wires. So I do this little diagram. Here's the board right here, and there's wire 1 and wire 2. And the man's standing at 4 meters. So I first write down what was given, which window cleaner is 80 kilograms. Board is 24 kilograms, and we don't know wire 1 and wire 2. So first I write down the formulas that I think I'm going to need to use. We're going to write down torque. Torque equals force times radius times sine. I also need work by gravity, which is mass times gravity times height. So the first thing I'm looking for is wire 1, the force. So I take the work gravity formula and I set it to each other. So I'm taking the information from this side and setting it to this side to give me this. So I take mass is 80 kilograms of the man times gravity, which is 9.8 meters per second, times 6. Well, the 6 is coming from here. You're going to take 4, subtract 10 is giving me 6. So that's the height for here. Plus 24 kilograms times 9.8 meters per second squared times 5. Well, 5 is the equilibrium, which is the whole board is 10. You're going to divide it by 2, which gives you 5. So I go down and it ends up being, we simplify each side. So this each side is 4,704 plus 1,706. You add them together and the total force is 5,880, which is the total force of the whole thing. So you can't just do the total force because we're only looking for wire 1. So we end up setting it as the total force is 5,880 equals 10 meters sine 90 because it's on a 90-degree angle, a right angle. So we end up doing 10 sine 90, which it gives us 10. So that cancels that out. So we divide 10. We're going to take 10 and divide it by 580, which gives us wire 1 is force is 588 newtons. And we're actually going to do the same thing for wire 2. We're going to take the man's mass, which is 80 kilograms, times 9.8 meters per second squared, times 4 this time. Because we're calculating, we're only going to use this where he's standing to, the moment where he's standing. So we use 4 plus 24 kilograms times 9.8 meters per second times 5 again, because that's still the equilibrium, which gives me 3,136 plus 1,176, which equals 4,312. And we're going to set it again to 4,312 equals 10 meters sine 90. The same thing, 90 is going to cancel out because 10 meters sine 90 is just 10 because sine 90 is 1. You're going to divide 4,312 divided by 10 gives you wire 2, 431.2 newtons.